Okay, so in the second part of the video lecture, what we're going to do is first we're going to calibrate our colors so that we see both for the geometry as in the compositing part exactly the same result. Then we're going to do like a first operator, which is actually like color quantization, a function that you have in the compositing node, but in my opinion is not as powerful as what we can do right here. And then in the latest part of this session, we're going to make like different color setups, how the color is being represented in space. And so with having like this different spatial color representation, you'll see different results, different effects from the same filters being applied to it. Okay, so the first part, let's get over here. I'm going to remove this spreadsheet and I'm going to add again like the composite view. So with the composite view underneath over here, and right over here we have like the 3D view. Let me put this over here so we can see the result. Okay, so the thing which is not good, or is not correct at the moment, is the moment that we see the result over here with the girl with the pink rose. It's considerably brighter than what we see right over here. So this is something that we need to change. And the reason is purely because this is an 8-bit integer value, which is being converted into 3D geometry and then being read back in as a floating point. So we're going to change that. What we're going to do is we're going to go to the utility and we're going to convert our image. So we're going to set it from an 8-bit integer to a 30-bit floating point. And as you can see, the moment you do that, this image becomes equal, and so the 3D version of the image becomes equal to what we see over here. The same also if we look at the end result. Now everything seems to be in order exactly as we need it. There's just one thing I forgot when I was rebuilding this thing. It was like an issue before. This has to be set to position. I'm not going to read out the colors, but I'm actually reading out the positions. So now the positions are back converted into colors, as we can see it right now. Okay, so let's have a first test. And one of the things that we're going to do is we're going to emulate a tool, which is over here, the quantize tool. And so let's check over here. And as you can see, what it does, it lowers actually the color depth resolution of the image. So the higher I put it over here, the less colors that are going to be used. But the other thing that you can see as well is that suddenly it starts to come up with colors that we don't have in the picture at all, actually. So if we go a little bit higher, we have like these very pure greens and like these pure reds. And yeah, maybe they're in the image, but still, it's like a very, very poor representation of what we want actually from this image. So this is something that we can improve. Now, how are we going to do this? Let's get back to this result over here. Let's go to the subnet. And since we have everything over here as points in 3D space, what we can do right now is we can use a fuse sop. And with a fuse sop, we're going to snap the points together. So we're not going to reduce the amount of points, but we're going to snap them in such a way that they're very close and tight together. So if you look at this, that you get something like this. So if we're now going to put it back, and these points are going to be red for the point positions are going to be red for the color, we get like this very interesting result. So also now we have way less colors, but already much closer to what we had before. Now this is the result that we get in RGB space. And that's the whole thing. RGB space is not necessarily the best space to work in, not to do this kind of operation. So what we're going to do is we're also going to create like different kinds of spaces. So this one I'm going to rename to RGB space. Now the next one I'm just going to take a copy of this. It's going to be put into RGB to HSV. So red, green and blue to hue saturation value. Let's see if this works from the get-go. If it does something directly with. So now we see like a totally different kind of spacing. Let me just remove the points over here. So this was the RGB space. Now this is the HSV space, hue saturation value. So as you can see, we have like the value right over here, the saturation over here, in the height, and then we have the coloring over here. So if you really use now the same thing, we use a fuse value over here to set the points, we get something completely different. Now let's connect this one, and this is not going to get the right result, of course, because we are reading in HSV what we see right over here. So we still need to convert now the positions back to RGB space. Again, we create like an attribute wrangle. So press tab, attribute, attribute wrangle, and now we're going to set the position is going to be the HSV to RGB of that same position. So now we have the conversion back after we had like the points combined. So you see this result is completely different now. Although we have exactly the same type of fusing, we have now a different kind of result. So let's check the RGB result, and here is the hue saturation value result, which now clearly shows actually the clothing which has the different color. So again, if we play around with it, you're gonna see it is way better as a result. Well, I can do something else. I'm going to copy the parameter and I'm going to paste as a relative reference over here. And so let's add a switch node so that we can easily switch between both of our results. So this is the RGB and this is the HSV. We see clearly some differences over here, the clothing. Now again, if we're going to compare it to what we have right over here in the quantize, it's something entirely different. So this is the result from the quantizing, and now this is the result from our own tool, which is way closer to the source result, as you can see. All right. So these are like two spaces. Now there's another space which we can use. A third one that we will build. First of all, I need to rename this one HSV. And the third one I'm going to build is one in which we're going to use in which we're going to create some kind of a spherical shape, or it might be a cylindrical shape. Okay, so we're gonna have like a different space representation just to move it a little bit further, and also to show you that you can be very creative about it. So create like different kinds of HSV spaces or whatever kind of color spaces that you can think of, and they all will have different effects, of course, the way how you treat them. So the thing that we're going to do is we're going to create like a cylindrical HSV space. And especially why cylindrical? Because if you look at the U values, actually it's a value that you can wrap around, and that has some advantages over the other definition of space. So let's create another one like that. So we do this with a an attribute wrangle. And first thing that we're going to do is we're going to create a vector which we're going to call color, and that vector is the RGB to HSV version of the color. Okay, so that's the first thing. Now the second thing, how are we going to define this in space? Well, we want to get like a nice circle. So we have a value from 0 to 1, obviously. So that doesn't matter if we see it over here. if you look at the total size of our color space, it's for each value, HSV or RGB, always a value from 0 to 1. So how can we put something like that nicely into a circle? Well, it's always best to have like a very simple thing to play with, to try it on. So don't try to fix it immediately on the end result as you see it over here. So let's do it on something else. Let's start with a line. And this line is going to represent, let's say, a value in a certain direction. So we're going to set it to the X direction. And let's give it enough points, like 360 points. Doesn't need to be that much, but it doesn't matter. At least this is going to give us like a very nice circle. So how can we do this? Again, create an attribute wrangle. So what we want to do is we're going to create like a new position. So at P is going to be a circle. So we're gonna need two positions, a position for the Z and the X. So something is going to be round and in a circle. Well, the two functions that you use to create a circle are the sinus and the cosine. So let's see. Let's start by setting our vector, and we're gonna use the sine of the position variable in the X direction. The Y we're going to leave as it is, and then we're going to set the cosine of the same value. Position attribute X. And let's see what we get. Alright, so we see that we have part of a circle. Now, why do we only see this little part of a circle? Well, a sine is represented in radians. So radians is actually, we're going to build it up in two parts. It's actually times pi. So times pi, and pi is the value of 3.141592. Something like that. Let's do this for both values. Let's see what we get then. So now we're going to get half a circle. Or at least we should get half a circle. Oh, I see. I placed it outside. Something I shouldn't do, of course. It has to be placed inside. Now I'm just making it bigger, which was not the idea. So now we see something different. Now we see half a circle. So why is it half a circle? Well, it's quite simple. A circle is the diameter times pi. Now in this case we have like not the diameter but the radius. So how to solve that? Well, it's the radius times 2. So if we then also do this times 2. Whoop. Yeah, this one is now outside. It was not the idea. Times 2. So now we get nicely a perfect circle. So that's it. That's exactly the formula that we need. Okay, so we're gonna do this for the U value. So U saturation value. Okay, so let's see. At P is going to be set open brackets, and I'm going to do it on each new line, which makes it a little bit easier to read. So the U value is going to be the following. It's going to be set on the X and the Y. Well, I'm just going to copy this, what we have over here. So right over here. So we create our 3 rules, and then we end it like this. So this of course is not going to work because we take like the position. We want to have like the color. So this one is something that we're going to change. Change this into color, and we take the first component of it, meaning the U value. Color. That's the U value. Okay. So let's see what we're gonna get out of that. Nice. So we see like part of the image already being placed on a circle. Now there are many more things. The saturation. Well, the saturation is something we can set in height. So we use over here color 1. So now we have the saturation as height. And the last thing that we can do is we can also put it to depth. If we're going to use, in this case, the value. The value is something we're going to use for depth. So how do we do this? Because we have both for X and Y already those values set. Well, it's actually quite simple. We're going to multiply this result with that value. Color, and in this case 2, and we have to do the same right over here, times color 2. So now we multiply the position over here for both of the axes, and for X and Z we multiply it with the value. So if you multiply these vectors with this value, you're gonna have like depth differences. So let's see what this gives, and indeed it's what we see. So the brighter things are, the more they're pushed to the edge. The darker things are, the closer they are to the center. And there are all kinds of things that you can do over here, because you can imagine if you have like a much more colorful image, which goes much more around, in which you have like more regions, you're gonna have like the dark area being combined into one thing. So especially if you use, for example, the fuse function like we have it over here, you will have the result that some things are going to be combined. Now I'll show that perhaps with some other images. Now just for safety reasons I'm going to save my scene again, because I had some crashes in the past. It doesn't seem to be entirely stable with this version of Houdini. I hope you have less problems, but I mentioned it already. But anyways, this is something I can show you. Let's see if we can find a better image. Something more colorful. Oh, why is this growing all the time? More colorful. Flower, forest. I guess that has like a lot of different colors. Yes, seems to be a very colorful plate over here. Brightness, all things. I'm going to make it a little bit smaller. Size, average size. Garden puzzle. Wow, there's many nice pictures over here. Just take like a good one. Let's look at the image. I'm gonna take this one. Okay. So again, I'm going to make in Compositing a new file. Let's put that over here. Don't forget to remove the linearize non-linear images. And now let's hope and see if it connects properly. Okay, right. So now we see indeed what we have. So we have the brightness with all these kind of things, the total spreading. So now you get like a decent idea of what's going to happen over here. Okay, let's dive in back into the subnet and let's see what else we can do. For example, you could think, okay, nah, if we're fusing, I want to avoid that these things are going to melt together. So don't bother, just add, for example, 0.5 to it. But be sure to put these between parentheses, because if not, you're gonna have the multiplication being done first and then the addition. So now you would pull them a little bit apart. Of course, it's a big mess with all these neighboring points, etc. But this gives you already a good idea of what you can do. So now if you would fuse, for example, using the same thing, you see how those points are getting fused, and it would be totally different than what we see right over here, in which you're going to get like fusion within a different set of spaces. Now I'll show you some other effects later on, in which you see the difference between what you made over here and what we make over here. But the idea is, of course, be creative, come up with like new shapes, new forms, how to show this whole thing, etc. Another thing which I'm going to change is, right now the radius is actually too big. I'm gonna switch back to the other image because it's like a little bit smaller and we see better the result of a partial thing over here. So the radius, or the size of the circle, is a little bit too big. So the thing I'm going to add on top of that is right over here. I'm going to multiply with 0.5. And the reason with 0.5 is that I want to have it half the radius, as you can see it right in here. So it would fit nicely within the thing that we need. So nicely within one value. Okay, so this is just one thing. We've been able now to put it into a cylinder, but now comes the difficult part. You have to put it back. We need to get it back into this kind of HV space, so we can then convert it back to RGB. And this is a little bit trickier, because now you have to unfold the circle. Okay, so let's do that. Let's see what we have to do in order to get something like that as a result. So again, try it out on a very simple thing. So let's use, in this case, an attribute triangle again. Come on, connect properly, please. Oh, yes, thank you. All right, so what do we have here? We want to get like a straight line again. So at P is going to be, come on, set. And now we need to have like only the X direction. We need to get everything placed on the X direction. We know the rest, which is going to be 0, 0. So what should we use over here? Well, there's a great function to unfold actually a circle, and that's the arctangent 2 in this case. And so the arctangent 2 needs to get like a vector. So a vector of 2. So we're going to take the attribute position of x, and attribute position of z. So that's a very important function to know about. So you know about sinus and cosine, most people know about this. Now this one is equally important, the unfolding of it. Oh, I did something wrong over here. Oh, I used a comma, so it was my mistake. So now you see the whole thing is being stretched out to a nice line. The circle has been stretched out again. But don't be already happy about the end result. There are still some things that we need. We need to get it back to the value that we have over here. That's the first thing. And also, there's something else. We need to get it into the right order. Because if you look closer, it starts at point 180. And then somewhere in the middle, we have 0.1. So that's also something we need to change. Okay, so the other thing that we need to do is we need now to divide it by 3.141592, making it already a little bit smaller as you can see, and again the same thing times 2 or times a half is also something what you can do, which makes it easier, then you don't need to use the parentheses. Okay, now we have something which is like unit length again. That's fine. And the only thing left is we need to shift it by a half. So now we get it all at least at the same position. Okay, good. Now the reordering. Luckily it's not too difficult. The thing is we have to play a little bit with the signatures over here. So if you see over here, oh, I use minus. Now you see a total change in ordering. But now it's the opposite way of what we want. Okay, no problem. Let's play on a little bit further. Let's use it over here as well. Minus position X minus position Z. And there we have it. Okay, so that's exactly the formula that we need in order to get it right again. Good, this is our first step. Let's use the attribute triangle. And we can apply this formula that we have over here again on what we see. Good, first step. So let's see, HSV space, that seems to be more or less consistent to what we have. Right, and it's always important to check with this result, of course. So let's see what else do we need to do. First of all, I'm going to put it again like I did before, so that we can clearly see the differences for each element that we use. Now there's one other which is actually quite simple. Let us go over here. We use here the saturation value, which is being used in the height, and we can keep the saturation value the same thing. So that's going to be just at position Y. So that's one thing. Let's see whether that's correct. That seems to be more or less correct. Good. We're getting closer. Well, I'm going to deactivate the fuse for a while now so that we can see correctly if we're getting the right thing. And now is going to be the difficult part, because right in here we have like the length of this. So we need to make we have like a distance from the center over here. Now we need to get it back. Actually, I said it already. It's in fact the length toward the center from each point that we need to get over here. So in this case, we're going to use the length, and there are many lengths just use this one. The other one is to check the length of a string, and length 2, I don't know by heart, but I guess that it is something that still needs to be being rooted in order to get like the proper length. Okay. Let's see the length. So the length going to be the length of a vector. Let's see how this is being used. Also, I need to look at it for sometimes. Length. Not a VAP node. Not. Oh yeah, it's the fix function. We're gonna use the fix function. Okay, we need to have like a vector over here. Okay, so what is our vector? Well, it's very basically, it's just like our position, the length of our position. Now, this is not enough, like I said, and the reason is because we created a cylinder. So if we measure the length of the points which are very low over here, which have no saturation, then the length would be correct. But if we have like the length of high saturation, it's going to measure the length always towards what we see over here, which is not correct. This is much longer than what we see over here because it is adding the height at it as well. So for that we're going to multiply our vector over here with another vector. So let's create a vector flatten, and we're going to set this vector to 0, oh no, the other way around, 1 0 1. So if you multiply this flatten, then the y value is going to become 0, so every data of all the points is going to be lying on a circle around it, and so now our length measurement will be correct. So let's do this first. Length and multiply it with flatten. So let's see what this result is going to be like. It's not going to be correct yet because we're still missing a few things over here that we did. So let's see. So this is coming already a little bit closer. As we can see, this is still longer, right? And it also has like an offset. So the length also has to be multiplied by 2. Remember that we halved it before. Hang on. So now we see we have actually the same shape. We're almost there. Just the last detail that we need to do is we have the whole length, and now we're going to subtract half from it. And now I think we're spot on. Okay, as we can see, there's now no difference anymore. We can go back and use this node that we created before again to convert from the HSV space to RGB. Well, if you want to, you can do it right away, but anyways. So this is the last part of creating like a different space. Now in the following video I'm going to show you a few things how we can play around with all the values, etc. Again, as you can see, we have like now different kinds of colors that are being snapped because of the new setup that we have. Okay, that's it for this part, and the next part we're going to play around a little bit with more image functions. Just the last thing before we do that, let's see what we have over here. Let me dive in and make sure this is locked so we can play a little bit around with all the different results. So this one was the RGB result, this one was the HSV result, and this one is our own HSV result, which was being placed inside of a circle.